Hello developers, let's start developing. We have on the menu the day 5 of the 2023 Advent of Code. First of all, let me start that I definitely feel that I'm gonna hate this task. So, we need to do some mapping, we do need to do some transferring. I definitely feel that this is gonna be a two-parter just because the processing is gonna be a bit weird and manual and tedious. And also, this definitely also, again, definitely reminds me of when I was a young developer that got tasked to clean up the main streets of Skopje. Actually, the story is that I was working for a huge enterprise, and that enterprise had at least four different systems that had an address map. And of course, the IDs of the streets and locations and whatevers were totally different in most of them. And I think there were actually two systems that started the same, but that then kind of diverged. So it was a bit on the weird side. And I had to write a lot of code that was basically like this. If in this system you have the ID 7, in that system you have the ID 10, and if you have 10 in that system, that means you're 25 in the other one. And there was a whole service that did a lot of lookups, but at the end I managed to clean it up. So we only had one source of truth for that. But the weird part of this is that whatever we're gonna do, this part is gonna be bad. So parsing of the input is not gonna be a fun thing. Just let us check that we had the same maps. So we have seed to soil, then soil to fertilizer, fertilizer to water, water to light, light to temperature, and temperature to humidity, and humidity to location. And we need to find the location, and it seems that it's a straightforward. This, that. So we need to run the pipeline, so to say. But in order to run any pipelines, we're gonna need to have some input. And the input will be, well, let's just call it almanac, because this is data from a island almanac. So this means that we will have the seeds, which will be a number array. And after that we had so and that is a mapping. So I will also have defined this type, which is a mapping, and it's actually a number and then a number and then a number. And these numbers are basically start and no. This is the initial source ID, destination ID, and duration. So this means that starting from 50, we need to map to 98, and that mapping is valid for two steps. So 50 and 51, and 52 maps to 50, and 53 maps to 51, and so on and so forth. And that goes on for 48 items. So this will be a mapping array, because we have 1, 2, 3 mappings, and we have 4 mappings, and so then we have fertilizer. And then we have to water, and somebody might have solved this before me, so no. To light, and then to temperature. Oh, it's just making an educated guess. Now, we're gonna have to have what kind of structure do I want? I want something that will be so yeah, it will be something like key, which is a string. How do I add this? Oh, I need to use these, I think. I failed to remember the exact syntax, but what I want to do is to have yeah, this works, but if I want to say, have C, this is a string, huh, this used to be possible. So I have no idea how to model it, but I'm still thinking on how do I want to have this. Let's have it with all the things, and then we will think about that when we're using it. Because I want to have this somehow more formal, maybe. But at the moment, I still don't know how. I don't have a feel. Anyway, our reading of the lines will be weirder, so to say. So I'm gonna hard code a lot of things. We can replace this all everywhere, so we always have that. Yeah, we're just gonna do that -1 and -1. And this is supposed to return a almanac. Yeah, this is okay. Return the result. But now we have our input lines and what we need to do. Here is the input. So the first line is this thing. And I will use quite a few regexes for this. So this is SEDS. Oh, this is not the regex, this is the things, and we are writing here colon space and whatever's. Actually, since this is a seed, yeah, I like it to be this way so it's a bit more lenient. Otherwise, we can just say, well, we have 6 or 7 characters, just lop them off and do everything else. But you might have noticed that I like regexes sometimes. So what we're gonna need to do? Let's say the seed line is lines.shift, and we're gonna use shift a lot because we're gonna be taking elements and using them. So we have the seed line match not on that, but match on this. No, match on this. And we want to make sure that we get everything. I mean, regexes do that, but still. Yeah, I'm gonna use a lot of this and also the exclamation mark because in this case I know that the input is in the correct format, but in general we just cannot guarantee that. So we might have a first line, we might not have a first line. So I'm just gonna say like this. So now seed line is a string. It's not a maybe a string. So that's the seed match. So we're gonna split on a space. Do we have single digit? No, even if we had single digit, we only have a single space everywhere. And we are getting just the number, so splitting on a space is just fine. We're gonna split on a space, parse it, note the number in the base 19, and those are the seeds. Okay, so then we have what? We have seed to soil. And what I will do, I will read this thing. So I'm gonna assume that this is in this format. So we need to skip a line. So we're skipping, in our example, we're skipping line 2. Let's have this into the input as well so we can see maybe some things. Yeah, so we need to skip line 2 and then focus on line 3. So we're gonna start by skipping line 3. Because line 3 is just some text that we kinda know what it is. And then somebody already did a lot of things, but I want to say, I will say actually let line equals of this, so we're getting a line. Actually, I'm getting an idea right now. It doesn't really matter what we're mapping to because it might come in handy in the second, so I might mess it up for the second part. I have no idea what the second part is. Seed soil, but the first part is a straightforward mapping in remapping. So this means that I'm gonna do this. So I can say just while lines.length is bigger than 0. Well, we do have lines. And at the moment, we are at line number 3. We are here. So what we need to do? We were gonna need to skip a line. lines dot shift. And then, yeah, we're gonna need to initialize a mapper. And then we need to take the next line. Yeah, that's the line for the mapper. And if that line is an empty line, we break. Yeah, we're gonna, oh, do we break? Actually, we continue because this is the code that occurs for each of the lines. So I will actually do this and then have another while. So while the mapper line is not empty, we loop. And it's gonna be something like this. Let's see if this, no, that's not the regex that we want. And yeah, I will use a regex so that I will know that we are getting only 3 numbers and we don't have a mess in the input. So if we have this input here and we put it over here, well, the regex is totally simple. We are starting and then we have a few numbers and then we have a space and then we have a few numbers and then we have a space and then we have a few numbers. And you can see that all of the mappings are actually matched. And now we just need to extract those strings basically because regexes only work on strings, and you can see that we have our pretty numbers. Of course, splitting the code on a space would have worked just as fine, but now here we actually know, totally know, that we only have 3 and exactly 3 numbers, not more, not less. So we have the first match, the second match, and the third match, and on the mapper we're gonna push exactly that. And we refresh the mapper line. But what happens when the mapper line is empty? Well, we just loop again. This might work. It's a bit less complex than what I imagined. But one way to find out. Let's start task 5. And it, of course, exploded. Why? Because we didn't have a match. So the seed line is that. Let's see what the seed line says. It's seeds. What do you mean you don't have a match? We definitely have a grouping over there. So we should both have a match and have a group inside the match. Now, am I doing anything wrong? Because I don't think I am. Only this thing is behaving weirdly. We don't actually need this. So we do have a match and we do have a group. Yeah, this is regex match array. Okay, if it doesn't work this time, I'm cutting seeds off and I'm doing another thing. Nope, it says it only has one thing. How can it have one thing that is the whole match when I have specifically a group specified here? Same flex, same everything, but something just doesn't like working. Okay, regexes. If they're working, it's great. If they're not, it's a problem. So I will just say seedline dot substring starting from seeds a colon, so starting from the seventh character. Cannot let properties of undefined. Yeah, this is possible if we get to the end of the task and it's actually not equal to an empty string. We successfully got on the string and then we got absolutely no mappers. Okay, this calls for a debug session. I'm doing something wrong and I have no idea what is this. So I have auto attach configured, so that means if I start it in the console of this thing of VS Code, it will actually do this. So let's see what the lines are. Yeah, we have the lines, 33 of them. So the seed line is that. The seeds are that. And we have 32 lines. So now we have 31 lines. And we are skipping that line. So now we should have, yes, the correct thing. So what is the mapper line? The mapper line is 5098.2. Let's see what the match is. Why is it not capturing the groups? Am I doing something wrong? Because this used to... Let's see what I'm doing in the other days. I might be having a brain fart situation. Is the G messing me up? I mean, I have read through the ECMAScript Regis specification a few times, but it has a lot of moving parts, and to be honest, I might be missing something. But no, it still doesn't work even without the G. So match takes a regex, and then we're getting back the match, and now we have the groups. Okay, it was the G. Oh, and now we have another problem, which basically we defined our mapper, but we forgot to add it to the result. Yeah, you kind of need to do that as well, otherwise it's not very operational, but let's see now. Nope, empty mappers again. Helps if you save it. Okay, let's assume that the values inside of them are correct, because there will be a lot of checking that we need to do. And let's just see if we manage. So seed to soil has 2, soil to fertilizer has 3, fertilizer to water has 4, and then we have 2 and 3 and 2 and 2. Let's just do a random one. So input dot mappers, and let's take the third mapper, 0. Where are you? So 0, 1, 2, 3, and the second value, the one value, 18, 25, 70. Let's see if this will give us something like that. So the third mapper, and give us the second field of that. Let's see if we get something that we want to get. The correct answer should be 18, 25, 70. 18, 25, 70. Yes, seems that our mapping is fine. And now we can actually take a look at the task itself. So far, all that we've done for a half an hour was mapping the input, but the input is finally mapped. And we can say, okay, now we have the correct values here. So what do we want to do? We want to start and map the seeds. So what we want to do is say that to find the, what was the name? Location number. We're going to take the inputs seeds and actually map them. And for each seed, we're going to say process seed, something like that. I will do this. I don't need the max. I can do that later, so we can have location dot max. Of course, I do have a method for that. So we're gonna have a method called process seed that will take a seed and an array of mappers. And what it will do, it will say for each of the mappers, we're gonna have result, not location. And we're gonna say that the result is process mapper with this result and that mapper. And then we just return the result. Of course, we're gonna have a process mapper that takes a this, and we're gonna need to actually do the mapping. So how do we find out whether our number is correct? So what we will do, whether this mapping applies to us, and that seems to be not to be too hard to do. So we have 79 here. 79, 50 to 51. And you can say, if it's bigger than 50 and less than 50 plus 2, then this mapping applies. and it's bigger than 52 and less than 52 plus that, the mapping applies. So we're gonna need to go through all of the private mappings. Just a sec. Uh, Through all of the specific mappings. So for of, again, mapping of mapper, and we can run our check whether that mapping is applicable. And note that it is kind of set in the task details that it won't be there won't be overlapping mappings, because then we will have an invalid state. So we can just say if seed is less than or equal to mapper, and actually I will do, instead of doing this, I will deconstruct this. So we can have source, destination, and duration. So if seed is less than equal than the source, and seed plus duration is less than the source, and we are non-inclusive on that part, then we just need to return not the destination, but the destination offset by, where do we, oh, I wanted to add another parenthesis here, then we're okay. Then we are returning the destination, but the destination matches the source, so we need to add the difference between the, no, we don't need the duration, the difference between the seed and the source. So this means, let's go through this. So we have 79. And 79 is actually between 52 and 50. 79 should be mapped to actually 77. So we have, we take the destination 50 and we add the seed, which is 79, and then we subtract the source, which is 52, and we get 77. So 51 would map to, we have the destination 98, and then we add 51, and then we subtract the seed, so 51 would map to 99. So our formula seems okay. And since only one of the intervals will map, we can just return the value. Otherwise, if none of the intervals map, we just don't map. We return the input. So let's see if this works. If everything went as well as I hope, we would have actually a solution. So it says 39. I have no idea if that is correct. It says no. Whimper. Let's see what we got wrong. We got multiple things wrong. First of all, we're not looking for the maximum, we're looking for the minimum. But on the other hand, out of these numbers, 39 is not the minimum. So we're gonna need to do some more debugging. 79, 14, 15, 5, 13. And we have 79, 14, 55, 13. No, this says 12. Okay, so now we're gonna do something else. We're gonna log a bit of things, some things. So we're processing seed, input mappers. We're gonna say no, we're gonna say yeah, we can do this. Just this, and then here we can say a console.log. We don't want it to be pretty, we want it to be functional. So each of these should give us the array of mappings that we get. So we have 79 and we're mapping 79 to 79. That is incorrect. Okay, that's great because we messed up on the first thing. So, okay, we are debugging. We got over that. So the mappers, we can see that the first mapper is 50, 98, 52, then have 50, 48. Great. Let's see what happens. So we're going to process our first seed, which is 79. The result is 79. And the first mapper is that mapper. So let's process the mapper. So we have our source is 50, our destination is 98, our duration is 2. Just a second. Yeah, okay, that's the first one. Is 79 less than or equal to 50? No. Is 79 plus 2 more than 50? Yes. Yeah, but who cares about that? So we have an end. Is 79 less than the source? Oh, bigger or equal to the source? Yep, math is hard. And logic is even harder. So let's see what happens. Did we save it? No, we didn't. So let's see. Now we're getting some different numbers, which are more incorrect, if I can say so. Okay, seems that our process is okay, but no, it cannot be like this. It's definitely wrong here. So what we have, we want the seed to be bigger than the source. Yes, but we have to have kind of different borders. So one is more than, one is less than. So the seed should be between 50 and 52, or between 52 and 100 for those things. So this means that it should be more than 50, more or equal to 50, and that's the source, and less than Copilot. You betrayed me. Less than the source plus the duration. Yeah. So this is an example when you make the first error, then Compilot will help you make the next errors as well. Yeah, just continue running to see if we have some kind of errors. 77, 77. Nope, it's supposed to be. Actually, oh, we're mapping it just the wrong way around. 79 is supposed to become 81. No, it's supposed to become 77 if I'm getting this right. Seed to soil. We are mapping 52, the seed number to a soil number. The range, the destination. It's better if you read the requirements. Everything is okay, only we messed up the source range and the destination range. So we don't have a source destination duration, we actually have the destination source duration. So we mapped it the other way around. Of course, reading it didn't make any difference for us, so let's see what happens now. I think there's something off with me because I keep not saving the date. So let's see what happens. This time, now we are going from 79 to 81 to 81 to 81 to 74 to 78 to 78 to 82, which is the correct value. 14, 14, 53, 49, 42, 42, 43, 43. Okay, so I'm just gonna check the last one, 86, 35, and the result part 1 is 35. Seems great. So let's take the huge input, let's put it here, and let's remove some console logs that we added. And let's give it a go. It says that this is the result, so I'm gonna believe it because I have more or less no way to check it. Seems that it was working. Okay, we're done with part 1. We're gonna continue to part 2, but I definitely feel that it's gonna be a two-parter when I solve this in the evening or something like that. Everyone will start if your planet only has as much small number of seeds. Reading the almanac, it looks like the seed actually describes ranges of seed numbers. Aha! Within each pair, the first value is the start of the range and the second value is the length of the range. It's seed number 79 up to 92, 52, 55, 13. 27 seed numbers. And on the other hand, this means that we're gonna have this many plus this many plus this many plus this many. And let's just see what this number is. It's actually 139 million. So we might need to run the loop a few billion times. Yeah, this is, no, this is 110 million. This is 18. Oh, this is just 8 million. It's nothing. So it seems that Yeah, we're gonna need to run our loop a few more times, which means that we might need to do some kind of optimization. Mhm. Okay, so it means that I have several ideas about this. One is to just try to brute force. For modern machines, usually several million things is not so much. Let's just do that and then we're gonna call it a day. So if we had our input, we can just say input dot seeds. Let's see what the length is. It should be an even number because we have pairs. So we have 20. So which means that we can just input dot seeds dot filter. So we have a seed and we have an index and basically give me the ones that have a index 0, index 1, where the index divided by 2 is equal to 1. And then just sum them up. Let's see how many runs do we need to do. It will be about a billion, I would guess. And for 40 runs, we have a few milliseconds. And this is 3 and 3. Oh, 1.5 billion. So if we have a millisecond per run, so and then we have 1.5, no, 150000000, and then we say we run through 1,000 every second. It means it will take 1.5 million seconds, which divided with 36 in an hour. Oh, it will just require 416 hours to just run this. Well, we might leave it running for a month. It will give us a solution, as it seems that the problem is not. But we need to somehow basically now parallelize the mapping. We need to analyze the data and say, well, something like this. If we have, so let's say we have 79 and then we have 14 more. So we are going from 79 to 93. 79 and 93 are all within this range. So we can just map them at once. We don't need to call all the methods and everything. So we can just map them and say, well, this is the first one, this is the last one, and this is it. So we're going to need to map interval, not to map each individual part of that. So we will be doing something like that, but that will be a separate video. For now, keep developing and see you when we solve the second part.